Alright, for this question, it asks you to find the relative extrema, any relative max or min, or saddle point. So recall, your D will be f of xx multiply f of yy minus f xy square. So in this case, it will be g of x, your partial respect to x, will be 2x minus 5, and your partial respect to y will be negative 2y minus 6. Now let's find a critical point at when x and y equal to 0. So you set both equations equal to 0, and then you can solve for x and y. So 2x equal 5, x will be 5 over 2, and negative 2y equals 6. Y will be negative 3. Now let's find the second partial derivative respect to x. So your g of xx will be 2, and your g of yy be negative 2, and your g of xy will be 0, because from g of x right here you go to respect to y. There's no y in this there's no y variable in this equations, so your partial respect to y will be 0. So now you have all the components to find a d. So your d would be 2 multiplied for negative 2 minus 0 square will be negative 4, and negative 4 is less than 0. So you would have a saddle point at x equal 5 over 2 and y equal negative 3. So now the only thing that you have to do left is to find z. To find z, you will just plug in x and y into the original equations. So you have 5 over 2 square minus negative 3 square minus 5 over 2 minus 6 negative 3, and your z will be 11 over 4. So finally your answer, the saddle point at 5 over 2 negative 3 and 11 over 4. This is your answer.